But the topic of this video is going to be about R and Python. So toward the end of the class here, I just want to move into talking about the database, sorry, not database, data science languages in general. And the two big hitters in data science right now are R and Python. And so I want to just provide some context on the similarities and differences, and then I'm going to wrap up the video with doing writing a small program in JavaScript, R, and Python, so you can just compare them side by side a little bit. And so I have made up a table here, and I will post this slide on under the Week 8 materials. But this is just Python versus R according to me. So this is based on facts of the language, both languages, but also my experience using both languages. So this is just sort of my summary of the difference between the languages. So we've talked about the fact that R is array-oriented. That's why its most basic units are vectors or kind of plural forms, and it's able to easily apply functions to lists or multiple elements within a list. And Python is more considered object-oriented, and I mean object in the sense of a JavaScript object, if you're familiar with that from the JavaScript class. But I also want to point out that Python can easily function as an array-oriented language, and this is usually done with the plugin or package NumPy. And so this is something that is installed for the Python, the Arpai that's running your ArcGIS program and stuff. So this is basically making Python into an array-oriented programming language, or it has all of the features of doing those being able to handle those multiple dimension arrays that R can handle in base R. So really the type of paradigm that they're known for is not a true difference of the two. R is an interpreted language and Python is both interpreted and compiled. And you don't need to know the details of an interpreter and a compiler, but this is what makes Python very high performance. It's fast. You may have noticed in this class that R can slow down with certain tasks, and Python has, they have focused on the speed and the performance of this language. So it actually does add up, and I think it's partly one of the reasons why Python is used for behind the scenes in ArcGIS. This next one I think is a pretty key difference between how these two languages function today. So they both came about in the 90s and were both data science languages. They were marketed towards data science, but R has stayed pretty domain specific within statistics. They've focused their tools around statistics and tools for getting jobs done in that realm. Whereas Python has been more of a general purpose language. It interacts on the web. It does Internet of Things, so think about the Python scripts that are running on those Raspberry Pis. It can do a lot more things, and this is the main reason that by far it is more popular in R than R in that there are more lines of code written in Python, far more than R. A lot of the things that you use on a daily basis have Python code. Your MacBook, Facebook, Pinterest, ArcGIS, it's just a lot more widely used. But one of the things that I personally feel R does a better job of is their support for data visualization and some of their packages for doing that, like ggplot. And Python, yes, it has those packages. You can definitely produce the same beautiful visualization in Python, but their packages are known for being a little more difficult to work with, tedious, specifically the data visualization packages like Seaborn and Matplotlib. Those are two that are commonly used in Python. But I have always preferred ggplot. If I'm just trying to do a visualization, I might rewrite it in R just to use its visualization tools. So that is a big bonus on the R side. And kind of going along with that, the user-friendly integrated development environment that you guys know as RStudio is very user-friendly. It wraps up those tools in R very nicely, and it has the consoles and file directory and the text editor. There are some for Python as well, but it's a little more bare bones. It's got a simpler syntax, so some people really like learning it. It's a good first language to learn, but I wouldn't call it more user-friendly, at least when you compare it to the RStudio duo. And then they both have very large communities, very large data science communities. But I do want to point out that Python, recently I saw a post about the most talked about language on Stack Overflow, and that used to be JavaScript. And the post was saying that Python has even surpassed JavaScript to be the most popular on Stack Overflow. So, like I said, it's related to it being a general purpose language. There's a lot more code written in Python, so it's even growing in popularity now, even though it's been around for a while, about the same amount of time as R. And we've already kind of talked about this, more statistic tools in R. I guess I wouldn't say there's more than Python. A lot of times if there's a stats tool, I'll find out that it's implemented in R as well as Python, but there's more of a support system and popularity around those tools, like the tidyverse are a very popular package for working with data in R. But Python has more tools and packages overall. So as I mentioned, there are like 13,000 packages on CRAN, the package index for R, and we're into like maybe 500,000 in Python. There's just orders of magnitude more tools available for Python. And then I just want to compare some of the data types across 3 languages that have been talked about in our program, just so it might help a little bit when getting to Python with any confusion between the different data types. But this is kind of an approximation of the comparison. They're not all exactly equal. I just wanted to show what data types might be considered equivalent to the R data structures. So the one that we're very familiar with in R is a data frame. In Python, this would just be what's called a dictionary, but it would be a certain type of dictionary that has a fixed number of rows per column, right? Because you have to have that data frame structure, that table structure. But a dictionary in Python is just a list that can contain multiple types, data types within it. So that's why I have it next to list. I have dictionary, because those are the 2 equivalent data structures between R and Python. If you remember JavaScript, this is the same as object literals, where you would have like the key and then the value. The key you can think of as, if you're thinking of a data frame, you can think of the key as the column name, and then the values within it are the different rows within the column. But object literals in JavaScript are pretty equivalent to dictionaries in Python, in that they're a container that can have different types of things, different types of data types within it. For a vector, that's kind of unique in R in that it's a list that everything within it is the same data type. And so I just have that. Technically, you could have something like that in Python. It would just be a list where everything is the same type, but lists don't have to be like that in Python. But they're called lists in Python when you have a one-dimensional container of things. And in JavaScript, you called that an array, which is kind of confusing. But I just wanted to put that in there in case you came across that later and got confused as what these different languages are referring to. Unfortunately, the language used to describe these different data structures can vary by the programming language, and that gets confusing. As far as objects go, if you've taken JavaScript, you're familiar with the idea of the constructor and the prototype and how you can inherit from that constructor object to create more objects. Python is like this as well, but it's a class system. They call those objects classes. And R also has a concept of this. So you may see somewhere in the R script or in an error message or something, it'll say something like object S3 or class S3 or S4. It's referring to S as in the programming language that R came from. So these are object structures that are inherited from that programming language that came before it. So I just wanted to point that out in case you see this S3, S4, it's referring to R's form of object inheritance. And we already talked about this, the multi-dimensional arrays as a data structure in R. You can get the same sort of functionality in Python by installing NumPy, and I'm sure there's a way to do this with JavaScript as well. I'm not quite sure what the package is, but I'm sure there is a plugin for doing that, perhaps in Node. And if you haven't taken JavaScript, haven't taken that programming course, don't worry about it. I'm just using it as a comparison over here for those that have. All right, so finally, let's just get to some syntax differences, and I'm going to actually type out a program in each of these languages just to demonstrate, but I wanted to pull together the main syntax differences that I see. These are not the only syntax differences, it's just these are ones I think that might be good for you to look out for if you're moving from R into Python, or vice versa. So the main thing is, for function scope, I'm referring to functions in this first line here, you use your curly braces for everything that is within the scope of the function. In Python, it just uses white space for this, so it basically just uses the tab, how many tabs you are, to determine what is within the scope of the function, and we'll see an example of this when I type it out. But this is the main thing to look out for. JavaScript and R both inherited that function syntax from a similar language, but Python is known for just using white space as its scope. And this makes it more readable, but can be kind of tricky for people that are just starting out. You're familiar with how to define functions in R. Again, it looks similar to JavaScript. Python's a little bit different. It uses def for define, and then you just give it the name of the function, which I'm calling myFun here, and then it will take it'll take the arguments in parentheses. And I have a typo here. I meant to put a colon. It will have a colon when the inside of the function, the scope of the function begins. So I need to put a colon in there. I'll just write that down so I remember. And again, we'll see that when I do the example in a second. I'm also putting in just an example of an anonymous function, which here is being called evaluate. That's just the name of the anonymous function. It's taking the argument x, adding 1, and then in R you would call what you want to pass in as x within the parentheses here of the anonymous function. The keyword for anonymous functions in Python is lambda. So this is the keyword here. Evaluate is the name, and then using lambdas, telling Python that this is an anonymous function that's going to take the argument x. It uses that colon and then tells Python what to do with that. And then for importing packages, you're familiar with doing the library call. So here's library rgdal. In Python, it's import, and I just realized I have another typo. No parentheses. I've been writing R too long, apparently. It's just import space gdal or numpy or whatever package that you're importing. So I will fix that too. Need to add the colon and get rid of the parentheses. This is what happens when you fall out of practice with certain languages. And one thing that always gets me quite a bit is the accessor, the $sign. So you're getting this column latitude out of the mydf data frame. It is a dot. It's usually represented as just a period in R. I mean in Python, sorry. It's the dot in Python. And this is why it bothers me a lot when I see the variable names in R. They might use a dot or a period as the space. That always messes with my head because I'm picturing that dot as being an accessor type syntax that is used in Python. It's also used in JavaScript too when you're trying to get a method or a function out of an object, and Python uses it in a similar way. So I just wanted to highlight that. And then the last thing I want to point out is if you're returning a result within an R function, you can do that return and then in parens the result that you want to return, the name of the variable that has the result, or you can just call the variable. You don't have to say return. Whereas in Python, it has explicit return. So if you're going to return a variable and it's not going to be called for its side effects or anything like that, you have to say return and then function result. So it's specific about that. So that's just something to look out for too. So these are some of the syntax differences that I've boiled down here, but I will fix some of those typos that I ran into there. Sometimes I find myself writing a mix of Python and R, and it's not good. However, there was a language called Arpai for working with both of them. I'm not going to talk about it today because I don't know if they're still supporting it, and I don't see a lot of people use it anymore. It was kind of a really difficult language to work with. And also, I'm going to post a YouTube video with what I do see used for working with Python and R together, which is a package in R called Reticulate. And basically, it opens a Python environment where you can type in Python code and analysis within it inside RStudio. And so I'm going to post a YouTube video where I think it's a group of people talking about class project where they worked on Reticulate. It's just a good little summary of the Reticulate package. So I will post that after I upload this recording. But now I'm just going to do an example in all three languages that I just talked about, JavaScript, Python, and R. And I'm just going to do this example from the Eloquent JavaScript book. Maybe some of you remember it. It was just printing out a triangle of hashes. And so I've just pulled it up in the sandbox here, and I'm just going to run it. So this was just a JavaScript for loop for printing out another hash each line. And I do kind of miss this for loop construct where it would have the initiation of the variable, the condition to stop the loop, and then what to do each iteration of the loop. That's something that I don't, see in R at least, and I kind of miss that for loop construct. And I also want to point out that this is the new syntax of JavaScript. Instead of var, it's let, so I'm trying to get used to that. But this is what we're going to aim for writing an example of this short little piece of code in Python and R. And so I think I'm going to write it in R first, here, just down in my console. And we're just going to be within the console for this. It's just an example, so I'll go ahead and get rid of the text editor there. And let's see, we're fairly zoomed in. Okay. So I'm just going to write a function in R for creating that same triangle typed text. And I changed my mind. I'm actually going to do a new R script because I can put this online later just in case anyone's interested. So I'm going to go ahead and give the function the name triangle. And it's just going to take a parameter n for a number of lines that we're going to print out these hashes. And then I'm going to do a for loop within it to create each line. So I'm just going to pick I as the variable and need to put it in parentheses because we're working with R here. For I in 1 through n, or the number that we give into the function of lines that we want. Now I'm going to use a couple built-in functions in R. I'm going to use the cat function, which is in base R, and this concatenates the strings together. So, but for this, we're just going to use a couple different functions. In fact, I think I'm going to use 4 just within this one for loop that are all base R. So to this line, so for each iteration of this for loop, we're going to print out a new line. I'm going to use the paste function, which you've seen before. We're going to paste some things together here. And I'm also going to use the function replicate. And this is a function in base R that is actually in the apply family of functions. So it says it's a wrapper for the common use of sapply for repeated evaluation of an expression. which will usually involve a random number generation. So that's what a lot of people use this for. But for us, we're going to basically use it as like an inner for loop here for telling the loop how many hashes should be added. So we're up to 3 functions in base R here. So for replicate, I'm going to give it that variable I for the line that we're on. And then the hash. So I is the element that will be on for each line that's generated by this outer for loop, and the paste and replicate are pasting on another hash each time we go to another line. And I also want to put in, paste will introduce a space between these 2 arguments. So just to get rid of that, I'm going to do a collapse function to get rid of that. And then finally, I need to tell it to make a new line every time, which is just the backspace n. All right. And hopefully I don't have any errors in here because I called a lot of functions for this one task. Okay, so I should be able to run triangle 5, and it's printed out a triangle with an additional hash for each line. And I can do however many I want in there because n is just the argument that that function is taken, and it will take any number, and do it for 1 through the range of that number. So that's just one way of doing it in R. As you may know, there are multiple ways of doing everything in R. This one doesn't make a whole lot of sense because it's using 4 different special functions within R, but it's also a little bit shorter. So I do have another example that makes a little more sense to me that I'm just going to type up really quick, and then we're going to do the Python comparison, and then we'll be done. So I'm going to call it triangle 2. Still its function, it takes n number of lines. It's still going to take a for loop, I in 1 through n. But then we're going to have an inner for loop rather than replicate. And you know that the apply family of functions, they are just implementing a loop behind the scenes, so we can recreate them with just an inner for loop, which might actually make this look a little bit easier. So I'm going to use j as the iteration value in this one. It's just a common syntax because j comes after I. And so I'll do for j in 1 through I. Concatenate cat a hash. So basically the inner for loop is responsible for printing out the hashes for iterating each element within that line, and the outer for loop is responsible for, this outer for loop is responsible for iterating through the number of lines, for creating the number of lines. So we close that for loop, but before we're done, within the outer for loop, we still need to do our new line. So I can do cat a new line character. And this should work in the same way, just using less built-in functions. There we go. So just 2 examples of basically using nested for loops in some way. One is more built-in function heavy. One is I think a little more readable and more similar in syntax to JavaScript and to Python, really. And so now I'm just going to do the Python example, which is going to be really short. And I'm just going to open my terminal here, just a new terminal session. So this is within my MacBook here, and Python's already installed on a MacBook. So if you have a MacBook at home, you can do this too in terminal. If you are working on a Windows, you may have Python already installed with ArcGIS. So there, I think ArcGIS Pro has Python console in it and stuff like that. But I'm just going to do it in my terminal here. I'm going to zoom in. All right, so I can just call in a Python environment here, and it's letting me know what version of Python I have installed right now. So now I'm in a Python environment, so it's ready to accept Python code. So I'm going to use that Python syntax to create a function, which is def for define, triangle, takes n number of lines, colon, needs colon here, and I'm going to do shift enter, tab, because the white space is its syntax for determining function scope. So no curly braces here. For I in range, I'll use range rather than those colons that we did, like 1 through n. So range is a function in and of itself that's looping. For I in range n, print I times a hash. So we can actually do arithmetic with the strings in this language. And I think that should be it. So I should be able to do triangle oops. Okay, there we go. I was trying to prove a point about how easy it was, and then I had an indentation error because it's Python and it's white space is its syntax. But this is all that the function is. And notice that there is a tab space for starting the for loop, the function scope, and then within the scope of the for loop there is another tab space. So it is using that to determine the scope. And then I just pushed enter, so that triangle was saved in there, and now I can call this triangle function in this Python environment I have with whatever number I want the triangles to be.